Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I'm your host, your host and as usual in the host mode Mohit Jain. और आज लेकर आए हैं मास्टर क्लास on a very simple topic that is highest common factor HCF and lowest common multiplier LCM. कहने को तो बहुत सस्ता टॉपिक है, बहुत सारे सिंपल से इजी से क्वेश्चन आते हैं, बट वी विल सी दैट व्हाट डिफरेंट काइंड ऑफ क्वेश्चन आर देयर व्हिच शुड बी सॉल्व्ड विद हेल्प ऑफ SCF and LCM, and towards the end we will see how to solve questions pertaining to successive divisions. So बने रहिए हमारे साथ and enjoy the session. Please don't forget to subscribe. उतना तो हक बनता ही है, मांग लेते हैं, बोल देते हैं. And subscribe to the channel, do share, comment, like and whatever, just help it grow. So on this note, let's start now. So let's begin the show and let's first offer you a simple example. Suppose we have three numbers 10, 20 and 12. Now if I talk about factors of 10, then factors of 10 would be 1, 2, 5 and 10. Factors of 12 would be 1, 2, 3. Factors mean the number which can divide the given number. So 12 is obviously divisible by 3, by 4, by 6 and by 12. Factors of 20 would be 1, 2, 4, 5, 10, 20. Now in this sets of factors, if we see that 1 is common, obviously 1 would be common with all numbers. 2 is common and no other factor is common. So common factors for these three numbers are 1 and 2, out of which highest common factor is 2. That is what we mean by HCF. As simple as that. बचपन में सिखाया गया होगा process 10, 20, 12. Identify the common factor of these three, that is 2. Then you will get 5, 10 and 6. Now there is nothing common in 5, 10 and 6. That means HCF is 2. That is how we actually calculate HCF. Now if we talk about multiples. So multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80 and on. For 12 it would be 12, 24, 36, 48, 60, 72, 84, 96. For 20, we have 20, 40, 60, 80, 100, 120 and on. So out of these three subsets of multiple, we can see that 60 is the number which is first common to all the three numbers. So we can see that common multiples to these three numbers are 60, then we will have 120 common, 180 common, out of which the lowest common multiple is 60, which is actually known as LCM, isn't it? And the basic method which we have learned to find LCM is we write all the three numbers given and start finding out the common factors. So it is divisible by 2, we'll get 5, 6, 10. Now 5 and 10 common factor is 5. We can write 1, 6 and 2. Between 2 and 6 common factor is 2, 1. It is divisible 3 times and then 1. Now we are getting 1, 3, 1. So in the end LCM should be 2 into 5 into 2 into 3. 6 into 10, that is 60. That is the basic method which we have learned how to find LCM. But this is what we mean by LCM, lowest common multiple, and this is what we mean by HCF, highest common factor. Now our job is to see that what different kind of questions can be asked where we need to use the concept of HCF and LCM, that we'll see next. So initially our plan is to just begin with a few basic examples where we just need to read and try to identify what to use, whether to use LCM, HCF or something else. Find the least length of the cloth which can be measured exact number of times using any of the three measuring rods of length 12 centimeter, 15 centimeter and 20 centimeter. We have three measuring rods. These are the lengths and we just need to find the smallest, the least length of cloth which can be measured with these three using it n number of times, whatever it is, that is something least, LCM. We are looking out for least common multiplier of 12, 15 and 20. That's it. 12, 15, 20 if we use our normal process. 3 or make it 3, 4 times, 5 times and then 20 will not go with 3. We have 4, 4, 5, 4 and then this is 1, sorry, this will go 5 times and 5. So 1, 1, 1. So LCM of these three number is 3 into 4, 12 into 5, that is 60 centimeter. So the least length of the cloth would be 60 centimeter or multiple of it, but the least length would be 60 centimeter, which can be measured obviously by 12 centimeter, 15 centimeter and 20 centimeter. If they ask you how many times it can be measured by 12 centimeter scale, then it would be 60 by 12, that is 5 times we require. For 15, if we are measuring this with 15 centimeter scale, we require it 4 times. And with 20 centimeter scale, we would be requiring this 3 times. We can see question based on these also, where we need to find these values also. We will see in some next example. But this is a simple question where we are using LCM. Okay, another basic question is on your screen. Please pause the session and try to solve it yourself and then look out for the solution. Let's try. So what is the question? Mr. A receives message from 3 different person XYZ every 6 minutes, 8 minutes and 12 minutes respectively. If he receives all the 3 messages at 10:30 a.m., then which of the following is the time at which he receives all the 3 messages again? So we need to find the cyclicity when all these 3 numbers would be happening together, that is nothing but add the multiples. And we are looking out for the least common multiple of all these 3 numbers. Answer would be simply, we need to find the LCM of 6, 8 and 12. Okay, 6, 8, 12. 2, 3 times, 4 times, 6 times, 3, 1, 4 and 2, and here we will get 4. 4 into 6 is 24. So after every 24 minutes, all the 3 messages would be flashing together, isn't it? It flashed at 10:30, then the next time would be plus 24, 10, 54. Add 24 minutes to it, it would be 11, 18. Next would be adding 24, 11, 42. Add 24, 6. That would be 1206. And add 24, 1230. And I'm stopping here because I can see 1230 isn't one of the option. So now you can ask that how long we need to do. Just do it. We have to pick up a value from the given options. So out of the given 4 options, it will again flash. All the 3 messages would be flashing again on the screen at 12:30 p.m. So another basic question on your screen, you know the process. Pause, try to do it yourself. So what's the question like? A milk vendor has 21 liters of type A, 42 liters of type B and 63 liters of type C milk. 3 different varieties of milk he has. He wants to pack them in bottles so that each bottle contains the same number of liters of milk. The volume of each bottle is same. And he doesn't want to mix any 2 types of milk in any bottle. What is the least number of bottles required? Now the word here is least doesn't mean that we need to find LCM. We need to find such a volume of a bottle uh, which can divide 21, 42 and 63. That means we are looking out for HCF of 21, 42 and 63. We can see that 42 is 21 into 2, 63 is 21 into 3, and 21 itself is 21 into 1. Then the common factor except 1 is 21. HCF is 21 liters. That means we will buy a bottle whose volume is 21 liters, so that we can pack all the three varieties of milk differently, and each bottle would contain 21 liters, and thus we would be able to find the least number of bottles required. So bottles required for type 1 is 21 by 21, that is 1 bottle. For type B milk we require 42 by 21, that is 2 bottles. And for type C we require 63 by 21, that is 3 bottles. So total number of bottles required are 6. The word least doesn't mean that we need to look out for LCM always. This is HCF because we are looking out for such a volume, such a number which can divide 21, 42 and 63 without leaving any remainder. We are looking out for the factor and we are looking out for highest common factor to solve this. Answer would be 6 bottles. Moving forward, we would be dealing with few properties and few formulas related to few numbers and the HCF LCM, and we'll see question based on that. And the different properties which we would be using for the next set of questions, 4, 5, 6, 7, 8, 9, 5 questions would be the property. First is like, in case if two numbers are given, A and B, in case of two numbers, A and B, product of two numbers is equals to product of their HCF and LCM. This is very commonly used property. In case of two numbers A and B, product of two numbers is equals to the product of their HCF and LCM. In case of fractions, if fractions are given, then HCF of fraction is HCF of numerators divided by LCM of all the denominators, and LCM of fraction would be LCM of numerators divided by HCF of denominators. Suppose we have A by B, C by D, E by F, then HCF would be, we need to find HCF of all numerators, that is A, C, E, divided by LCM of all the denominators of the fraction B, D, F, and LCM would be LCM of numerator A, C, E divided by HCF of denominators, that is B, D, F, and hence you would be able to find HCF and LCM of fractions. And another one more interesting properties which can be used as formulas if you want is if A, B are two consecutive even numbers, then the LCM of AB is nothing but half of A into B. As simple as that. If A and B are two consecutive even numbers, we have derived this property from property number 1. So based on these properties, we will look out for few questions now. So starting again with the basic questions related to those property. If LCM and HCF of two numbers is 180 and 18 respectively, it is given LCM and HCF of two numbers. And if one of the number is 36, find another number. We know that product of the number A into, suppose one of the number is 36, is nothing but product of HCF and LCM, 18 into 180. That means another number which we are looking out for is 180 into 18 by 36. 2 times, and this will be 90. So if you know the properties, we can solve this question in no time. Let's take the one more on the basics. Now based on the second property which we have discussed, HCF and LCM of fractions. You may pause it and then solve it yourself. It's simple. As far as HCF is concerned, it is HCF of the numerators. We need HCF of 1, 2, 3, 4, and that will be divided by LCM of 2, 3, 4, 5. So HCF of 1, 2, 3, 4 is 1 because only 1 is common here. And 2, 3, 4, 4 into 3 is 12, into 5 is 60. So HCF of these fractions should be 1 by 60. And let us calculate LCM. LCM of 1, 2, 3, 4 by HCF of 2, 3, 4, 5. LCM of 1, 2, 2, 2 into 3 is 6 and 2 gone, into 2, 12. LCM of these number is 12 and HCF 2, 3, 4, 5, only 1 is common here. So LCM is 12 and HCF is 1 by 60. Now they can ask different question based on this. What is the product of LCM and HCF of these fractions? So first we need to find LCF and LCM. Then product of LCM into HCF we can find it easily. 12 into 1 by 60. That would be 1 by 5. Or what is the inverse of LCM? What is the inverse of product of LCM and HCF for these fractions, which happens to be one of the question asked in TCS. So in that case, the inverse of product of LCM into HCF of these fractions is 5. So basics we should know, then we can answer anything whatsoever they ask. Give it a try. So I hope you must be having the answer by now, and you must have used property which we have discussed. We need to find the LCM of two numbers. One is a plus 1 and another one is a minus 1. First thing, it is clear that this is a. This number is after a, that is a plus 1, and this number is before a, that is a minus 1. That means these two numbers are consecutive odd numbers or consecutive even numbers. That is for sure, because a minus 1, a and a plus 1 are three consecutive numbers. So either a minus 1, a plus 1 both are odd, or a minus 1, a plus 1 both are even. Now let us see what is a. A is 4, 5, 6, 7. It is an odd number. Odd number raised to any power is always an odd number. An odd number raised to any power is always an odd number. That means a itself is an odd number. A minus 1 should be an even number, and a plus 1 should also be an even number. That means the two numbers given in the questions are both even and consecutive. So if x and y are two even number and consecutive even number, in that case their LCM is simply half into multiplication or product of x and y, the property which we have discussed earlier. So LCM of the given two numbers are 4, 5, 6, 7 to the power 2, 0, 1, 0 plus 1 and minus 1. Now we can see that these are of the form of x plus y into x minus y. And we know x plus y into x minus y is x square minus y square. So LCM in our case is half into 4, 5, 6, 7 to the power 2, 0, 1, 0 into 2. That is 4, 0, 2, 0. And minus y square. 1 into 1 is 1. Minus y square is minus 1. So final answer is LCM is half into 4, 5, 6, 7 to the power 40, 20 minus 1. Okay, another logic based question on your screen where we would be using concepts of co-prime. Please give it a try. So let's see. I still believe that you people have the answer by now. Sum of two number is 720. And the HCF is 24. HCF is highest common factor. So let me take the two numbers as a 24x, 24 into x, and b as 24 into y. Now only 24 is common between a and b. X and y, there is nothing common between x and y. That means x and y are co-primes. This thing we need to understand because HCF is 24. If there is anything common between x and y, then HCF of A and B would change. Now, according to the given information, A plus B is equals to 720. So we can say that x plus y is 720 by 24. It will go 3 times, that is 30. So sum of x and y is 30 and x and y are co-primes. We are just looking out for the values of x and y such that x and y are co-prime and x plus y is 30. We can start with taking value of x as 1. Then y would be 29 because x plus y is 30 and 1 and 29 are co-prime. We can take 2, 28, 3, 4, 26, 5, 25, 6, 24, 7. 7, 23. These two are co-prime. Then 8, 22 would not work. 9 would not work. 9, 21, 10 not work. 11, 19. Okay, 12, no. 13, 17. 14, 16, 15 will not work. And then again 16, 14, we are into the reverse mode. So these are the 4 possible values of x and y. Now, they are asking us, find the highest possible LCM of such number. Highest possible LCM would be 24 into x into y. We are looking out for the highest possible multiplicative value of x and y. That is again, if we know some format, that if sum of two numbers is given, x plus y is 30, then product would be maximum when the difference between these two numbers which we are selecting is the least. Here difference is maximum, here difference is least. 17 minus 13 is least difference. 21 minus 1 is maximum difference. So that is also one of the property that for the given sum of numbers, suppose sum of numbers we know, then product is maximum when both the numbers are same. That is the property. Along with that, we can use this property also that if sum of number is given, product is maximum for that pair where the difference between the two numbers is least. So out of these 4 pairs, the difference between the number is least is with 13 and 17. That means highest LCM possible is 24 into 13 into 17 on multiplication. It should give 5304 and that is our answer. Before that, I should say there are 4 of such pairs. So A 24 into 1 and 24 into 29. When we add up, we'll get 720. Their HCF would be 24. Their LCM would be 24 into 1 into 29, which is obviously way more smaller than 5304. We are looking out for the highest possible LCM and we have used 2 different kind of properties here. One, the concept of co-prime, and one that for given sum of numbers, product is maximum when the difference between the two numbers is least. Question is on your screen. You know the drill. Pause. Try to solve it yourself. Now let's see what is the question and hope you have the answer by now. HCF of two numbers is 15. That means my two numbers are 15 into x and 15 into y, and x, y are co-primes. Done. How many such pairs of number lie between 25 and 100? Now, the very smallest number between 25 and 100 which is divisible by 15 is 30. And the largest number between 25 and 100 divisible by 15 is 90. Now, 30 by 15 is 2 and 30 by 15 is 6. That means values of x and y would be from the subset 2, 3, 4, 5 and 6 only, and such that we need to choose two numbers from this 2, 3, 4, 5, 6 such that x and y both are co-primes. Let us do this pairing. If I choose x as 2, I can choose y as 3. 2 and 3 are co-prime. 2 and 5 are co-prime. 2, 4 and 2, 6 are not co-prime because 2 is common. Now if I choose x as 3, I will not choose 2 because I've already chosen. I can choose 4, and 3, 5 also goes. 3, 6, common is 6. If I choose 4, already chosen 3 and 2, 3 chosen, 2 can't be chosen. 4, 5 are co-primes, 4, 6 are not. And then with 5, I can have 5, 6. Great. So we can have 1, 2, 3, 4, 5, 6 pairs of x and y from the set 2, 3, 4, 5, 6, such that both the numbers chosen are co-prime. Now you'll be wondering what is this 2 and what is this 3. Actually, these are multiple of 15. So these are the values of x and y. So first pair is 15 into 2, 30, and 15 into 3, 45, for which the HCF is 15. Second pair would be 30 and 15 into 5, 75. Then 15 into 3, 45 and 4, 60. Then we have 45 and 5, that is 75. 4 is 60 and 5 is 75. Its HCF is also 15. And 75, 90. Its HCF is also 15. And whatsoever be the LCM, that is not asked. We have just been asked that how many numbers are there between 25 and 100. We can get that there are 6 of such pairs whose HCF is 15. So answer is 6 pairs. Give it a try. Now let us use some concepts of factorial. We know what is factorial. Factorial 500 means 1 into 2 into 3 into 4 till 500. Now, what is 501? 5 into 1, 6, it is divisible by 3. It is 3 into 167. 502 is 2 into 251. And 503 is simply 503 because it is a prime number. 167 is a prime number, 251 is a prime number, 503 is a prime number. That means y is actually equals to 2 into 3 into 167 into 251 into 503. And x is equals to 1 into 2 into 3 into ... into 167 into 251 into till 500. If we look at x and y very carefully, 2, 3, 167 and 251, that is common between both the numbers. That means we can delete this from this system because it already is there in x. Now 503 is not a multiplication or part of 500 factorial. That means since it is a prime number, none of its factor is there in factorial 500. So LCM of x and y is factorial 500 into 503. That can be written as 503x because x is factorial 500 and 503x is in none of the option A, B, C. Will mark on D. None of these is the answer. Actual answer is 503 into x. Now we have another set of 4-5 questions which are based on remainders and residue. We'll see that what kind of question can be asked. Like find the largest number. Find the largest number that will divide 887 and 1061, leaving remainders 7 and 5 respectively. Largest number. We are looking out for the factors. But we know that when we are choosing that largest number, when it will divide 887, we will get remainder 7. And when it will divide 1061, we will get remainder 5. That means first delete these remainders from here. So we are getting number 880 and 1061 minus 5 will give 1056. So we are looking out for the highest common factor between these two numbers, 880 and 1056. Here I'll take up another process to find HCF, that is known as long division method. Pick up a small number and divide the big number from the small number. It will go 1 times. 880, you get 6, 9, 15 minus 8, 7 and 176. Now divide this number 880 from 176. 880. It will go 585 and 5 times. Yes, 5 into 6 is 33, 17, 585, 880. It will go 5 times. That means HCF of these two numbers 880 and 1056 is 176. And this process is very handy. This is known as long division method, and this process is very handy in case we have two big numbers. Use this long division method to find HCF in no time. So the largest number which can divide 887 and 1061, leaving remainder 7 and 5 respectively, would be 176. If I divide 887 by 176, it will go 5 times and it will leave remainder 7. And 1061, when divided by 176, it will go 24 times. 24 times? No, 32. Whatever. 12 into something. 4, 8, 6 times. 176 into 6 would be 1061. And it will go 6 times and it will leave remainder 5. So let's see a few more questions. Give it a try. We are looking out for the number which, when divided by any number between 2 to 9, 2, 3, 4, 5, 6, 7, 8 or 9, leaves remainder 1 in all cases, and the number should be just greater than 5000. In such type of question, whenever divisors are given, that a number we need to find and divisors are given, first find the common multiple of all the divisor. We need to find the LCM of 2 to 9 and give it a try. An LCM of numbers 2, 3, 4, 5, 6, 7, 8, 9 would be 2520. So any number which is 2520 or multiple of 2520, when divided by 2, 3, 4, 5, 6, 7, 8 or 9, will leave remainder 0. First of all, we need to understand that. Now we are looking out for a number which is just greater than 5000, which we can see that if we find multiple of 2520 2 times, we'll get 5040. And it is just greater than 5000. And it is divisible by 2, 3, 4, 5, 6, 7, 8, 9. That means our required number is nothing but multiple of LCM of divisors between the given range. Whatever number is given, we need to find the multiple of LCM of divisors plus add common remainder. If we have a common remainder, just add that to it. So our required number is 5040 plus 1, that is 5041. So 5041 is a number which is just greater than 5000, and when divided by 2, 3, 4, 5 till 9, we leave remainder 1 in all cases. Give it a try. I know when you would be comparing question number 11 with this one, you will see one thing. In question number 11, we have a common remainder. We were dividing by few divisor and it was leaving remainder 1 in all cases. But in here, when it is divided by 2, it will leave remainder 1. When divided by 4, it will leave remainder 3. And when divided by 9, it will leave remainder 8. We will come back to this after some time. But step 1 is simple. We need to find the LCM of all the divisors. LCM of 2, 4, 6, 8, 9. 2 is there in 4, 4 is there in 8, 6 is there in this. That means 8 into 9, 72. LCM of these numbers, these divisors 2, 4, 6, 8, 9 is 72. Now we are looking out for the number which is just greater than 5040. Oh no, let's make it 5000, not 5040. It doesn't look good. That would be 5040. Maybe like from the last question we have mentioned this. Find a number just greater than 5000. Now how to find this? Divide 5000 by your LCM 72. It will go 6 times 18, 1, 432. Then 132 will give 68. Then it will go 9 times 72, 630 and 18, 648. So I'll get some remainder. Okay. So we are looking out for a multiple of 72 which is greater than 69. That means the number which should be greater than 5000 is 72 into 70. 41. That would be 5040. Bingo. So a number which is just greater than 5000 is 5040, which is multiple of 2, which is multiple of the LCM 72. And when divided by 2, 4, 6, 8 or 9, will leave remainder 0. But here we can see that they want to give remainder which are different. So we have divisor, we have remainder. Now divisor minus remainder, if we remember our remainder class, we know that we had this concept of residue. Residue plus remainder is equals to divisor. Divisor is 2, remainder is 1, then residue is 1. 2 minus 1. Divisor is 4, remainder is 3, then 4 minus 3, residue is 1. 6, 5, in this case also residue is 1. 8, 7, residue is 1. 9, 8, residue is 1. In this particular example, we can see that we have got the common residue, not the common remainder, but the common residue. Therefore, our required number is the number which we are looking out for in the given limits, that is 5040. And if we have common residue, we'll deduct the common residue. That is the format. If we have common remainder, we'll add the common remainder. If we have common residue, we'll deduct the common residue. So in this case, our number is 5040 minus 1. That is 5039. If we have common residue, deduct the common residue from the number which you have found in the given limits. And if you have common remainder, add it to the number which you have found multiple of the LCM in the given limits. This is on the line which we have done in question number 12. Pause. Do it fast. Quickly. So find the least number which when divided by divisors are 16, 18, 20. We are looking out for the LCM. 16, 18, 20. Okay. It is 8, 9, 10. 8, 9, 72. Into and 2 work out there 720. So LCM would be 720. Great. We are looking out for the least number which is divisible by 16, 18, 20, that is 720. But here remainders are different. If remainder are different, always go for checking whether residue is same or not. 16 minus 7 is 9. 18 minus 9 is 9. 20 minus 11 is 9. We can see that here residue is same. So the least number which we are looking out for is LCM minus residue. So that would be 720 minus 9. That is 711. Divide 711 by 16, 18 or 20. You will end up getting remainder 7, 9 or 11. So the last one from HCF LCM before we move into successive division, let's give this a try. A number is divided by 20, 25, 30, 36 and 48. Okay, we know we need to find the LCM of these numbers. We need to find the LCM of the divisors 20, 25, 30, 36 and 48. Work out, do it slowly, but do practice a lot how to find LCM by long division, finding the common factors, dividing it, whatsoever. LCM would be 3600. And the respective remainders obtained are 15, 20, 25. We can see that all remainders are different. So we'll go for the concept of residue. 20 minus 15 is 5. 25 minus 20 is 5. 30 minus 25 is 5. 36 minus 31 is 5. 48 minus 43 is also 5. That we can see that we have got common residue. Okay, we know what to do at the end. But do we have any limits given? Yes, limit is we need to find the smallest 5-digit number. Now, smallest 5-digit number is 10000, that is 10,000. We are looking out for a number which is multiple of 3600 and it is just greater than 10,000. We can see just by mere looking at it, we can find that 36 into 3 is 108. Correct. So 3600 into 3 will give us 10,800, which is multiple of 3600 and which is just greater than 10,000. If you can't identify the factor like this, then you know the process. Divide 10,000 by 3600 and just see, here we'll get it 2 times and we will get some remainder also. That means 2 plus 1 is 3. We are looking out for just one greater multiplier of 3600 than 2, that is 3. 3600 into 3, 10,800 is the smallest 5-digit number which is actually divisible by 20, 25, 30, 36 and 48. Now the required number, since we have common residue, is number in the limits minus common residue, that is 5. 10,800 minus 5 will give 10,795. 10795 is the number which when divided by 20, 25, 30, 36, 48 will leave residue 5 in all cases. Before we sum up this masterclass on HCF LCM, a small concept which we need to understand here is successive division and what kind of questions are asked. Let's divide 72 successively by first by 5. So 72 will go 14 times and we will be left with the remainder 2. Now if I again divide 14 by 3, it will go 4 times and we would be left with remainder 2 again. And if I divide this 4 by 3, it will go 1 time and we would be left with remainder 1. So what we can conclude? This is what we conclude, that when 72 is successively divided by 5, 3 and 3, it leaves remainder 2, 2 and 1 respectively. Now in question, this information is given. Now based on this information, they asked questions. Now let us reverse this conclusion and see what we can devise from it. Now let's see how to find the numbers and how question can be asked. A number when successively divided by 5 and 7, a number is there when it is divided by 5 and then the quotient is divided by 7, it leaves remainder 3 and 5. Now the thing is, they are asking what will be the remainder when the same number is divided by 35. But our task is to first identify what is the number. And now we'll discuss the very simple process to find the number. How we can identify the number. The smallest quotient here in this place can be 1. Now the quotient which should be here at this place is nothing but 7 into 1 plus 5. 7 into 1 is 7 plus 5 is 12. We'll write 12 here. You can see that when 12 is divided by 7, quotient is 1 and remainder is 5. Again follow the same process. 5 into 12 is 60 plus 3 is 63. That means the smallest of such number which when divided successively by 5 and 7 and leaves remainder 3 and 5 is nothing but 63. Clear? Now we can find many of such numbers. You can see if we start with 2, then 14 plus 5 is 19. 19 into 5 is 85. 85 plus 3, 19 into 5 is 95. 95 plus 3 is 98. 98 is also such number. So we can have many such numbers. Okay, let's give it a try with another factor. 5, 7, here remainder is 5 and 3. Let we have this quotient 3. 7 into 3, 21. 21 plus 5 is 26. We'll go up now. 26 into 5 is 130. 130 plus 3 is 133. So 133 is also such number when successively divided by 5 and 7 will leave remainder 3 and 5. Now, if we finally see, then when we are using final quotient as 1, we are getting number 63. If we are using 2, we are getting number 98. If we are getting like using 3, we are getting number 133, and all are correct numbers. Here if you see the difference between the number 98 minus 63 is 35. 133 plus 2, difference here is also 35. So this number series with common difference 35 and starting with 63 are all those such numbers which when successively divided by 5 and 7 leaves remainder 3 and 5 in all cases. Now different kind of question can be built around it. What is the total of all the numbers, all the first 10 numbers or the first 10 small numbers which when divided by 5 and 7 leaves successive remainder as 3 and 5. We can get an AP series and then we can find it. Now the concept builder is how to find this without actually putting 1, 2 or 3. It is nothing but as simple as that. First we need to find multiplication of the successive divisors, that is 5 into 7, that is 35, and that is the difference. The common difference would be 35. Clear? So the general format of the number is 35k plus we need to find the smallest of such number also, that is 63. Clear? Now k belongs to whole number. If we put k equals to 0, we'll get the small number, that is 63. If we put k equals to 1, we'll get another number 98. K equals to 2, we'll get next number 133 and so on. Now how to write the general format? How to get this 35? 35 is nothing but product of all the successive divisors into k plus. What is 63? 63 is the smallest of such number which we need to calculate putting q or final q equals to 1. When you do that, you'll get a number in the general format. So the general number of this format is 35k plus 63. Now the question is, what is the remainder when this is divided by 35? Bingo. 35k plus 63 is divided by 35. This is obviously divisible by 35. Remainder would be simply what you get when 63 is divided by 35. So remainder would be 63 minus 35, that is 28. So answer for this question would be 28. But why this question has been taken up? To build up the concept about how to find the general format of any number which is asked in the question. Okay, the last one for the day, and I hope everything is clear. If that is not clear, please write it down in the comment box. We will try to clear it up. A number being successively divided by 5, 7, 9. A number is divided by 5, then 7, and then 9. Leaves remainder 2, 4, 6 respectively. Okay, I'm not reading the second part. Let me try to identify the smallest of such number or the basic format of this number, which we will start by putting final quotient as 1. 9 into 1, 9 plus 6 is 15. Then we'll move up. 7 into 15 is 105 plus 4 is 109. 109 into 5 would be 545 plus 2. 545 plus 2 would be 547. So the general format of all the numbers we are looking out for is 9 into 7 into 5. 9 into 7 into 5 k plus 547. Bingo. This is our general format. This is the number which we are looking out for, where k belongs to whole number. K is 0, that the smallest number is 547. Now they are saying that if the order of the divisors is reversed. If order of the divisors is reversed, the next number would be of the form 579. Again, it would be of the form 9 into 7 into 5k plus something. Clear? Now, it is given that these two numbers are same. If these two numbers are same, and we can see that it is 9 into 7 into 5k, it is also 9 into 7 into 5k. That means this something is also 547. Bingo. We are just supposed to divide 547 by 9 first, then 7, and then 5, and we need to find the remainders. 547, 6 times 0, remainder would be 7, 7, 7, 7, 8, 56, remainder is 4, then 8 divided by 5 will go 1 time, remainder is 3. So the answer to the question would be, if the order of the divisors is reversed, then the remainders would be 7, 4, 3 respectively. Now we need to compare, because these order of divisor is just reversed. These two numbers, these two first basic initial number in these two cases would be 547. And all numbers would be same. So on this note, I'll give you few questions after this. Please try to solve it yourself and do write the answers in the comment box. And if you have any problem, please do let us know. Masterclass are a bit to digest. Please go through it again and do let us know if you want us to prepare masterclass on any other topic. On this note, have a good night and do subscribe to the channel. This is Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you. On this note, that I'll see you soon. Yes, I'll see you soon.